Assalamualaikum and good day. Today we're going to continue the last part for force vector part 3, which is we're going to study about the force and position vectors. What is position vector? Position vector is a fixed vector that locates a point in space relative to another point. A position can be defined by its coordinate in 3D space. A position vector denoted as RAB. Let's have a look for point A and B, where B is the ending point and A is the starting point. For both that point, we can identify what each coordinates, which is for A is XA, YA, ZA, and B is XB, YB, and ZB. To calculate the position vector for RAB, for each axis, for example, we take for X, XB minus XA, that's for I, YB minus YA, for J, ZB minus ZA, for K, and the unit in meter. So we can get our position vector for RAB. Therefore, for this part, you should able to imagine the coordinate for A and B in 3D positions. Here, the case in real life, as you can see, the ship tie on the piers, and also here you can see on the roof on this building. So you can get what is position here, you can get what's position here, then we can identify our position vector for this chain. Similarly, we do for another chain here and here. Next, let's have a look for this case. We have location B and A, where B located at intersection for each axis. As you can see here, on the x-axis, on this part is positive x-axis and another part is negative x-axis. Similarly for others, for example, for y-axis here, on this part is positive y-axis, on another part is positive y-axis. Let's have a look on z-axis. On this side is negative axis, and for sure this on positive. Now let's identify what is coordinate for A. So for the position or coordinate, we have x, y, and z. So let's find for x value first. For the x value is -2 because this move 2 unit on the positive axis on x-axis. So the value for that is -2. Now let's have a look on y. Here is 1.5. Move on positive side. So that is positive 1.5. Next, let's have a look on z. On z is going up 3 units. Here, up 3 units. Therefore, is positive 3. So, we get our coordinate for A. What is the coordinate for B? Certainly, for B is the origin, which is intersection. Therefore, coordinate for that is 0, 0, 0. Now let's do for example 2.12. This elastic rubber band is attached to point A and B. We need to determine the length and direction measured from A to B. So please make sure you are able to imagine this in 3D. So for this case, we need to establish the position vector for RAB from A to B. Therefore, to move from A to B, it need to go -3 meter in x direction. What does it mean? this is the x-axis. So from A to B, 1, then add another 2. So move to negative x direction, therefore is negative 3 meter. Next, let's have a look on y direction. So 2 meter in y direction. So this is y axis. This is A on here. So move 2 meter. That's on positive. That's why it's 2 meter. Next, let's have a look on z direction. So it needs to move from A to B in z axis. So this is z axis by 6 meter. Therefore 3 meter going up plus another 3 meter, so 6 meter. Therefore we can identify position vector for RAB. Another method we can use is, what is the coordinate for A and B? For coordinate A, 1 on x direction, positive, and for y is 0 because it's on y-axis 0 position. Then for z is negative 3, going down from positive here, so negative 3. Then how about B? So for B, on x is going to negative side by 2 unit, so negative 2. Then on y, move 2 unit to positive side on y-axis, so positive 2. And on z-axis, going up by 3 unit, so going up by 3 unit on positive side, so positive. So we get coordinate for A and B. Then simply we can calculate our position vector RAB by xb minus A for I, then yb minus ya, then zb minus za. We get our position vector for RAB. Then we have to establish our unit vector UAB. Position vector divided by the magnitude. So we need to find our magnitude RAB. We know our position vector negative 3i plus 2j plus yk plus 6k. Then we can calculate our magnitude. Negative 3 power of 2 plus 2 power of 2 plus 6 power of 2 square root, and we get 7 meter for our magnitude. This magnitude same to the rubber band's length. Then we can find our unit vector UAB. We know our RAB early on. Then we can calculate our unit vector. On I, negative 3 divided by 7 on the magnitude. Do the same thing for J and K. Then we get our answer for unit vector UAB in meter. Then we want to know direction A to B. We know the magnitude is 7 meter, same to the length of the rubber band. We know alpha is the angle from x-axis, positive x-axis, beta from positive y-axis, and gamma is from z-axis. We know our unit vector can write in this form. Therefore, we can calculate our alpha, beta, and gamma. For the alpha, we know negative 3 from our RAB, divide by magnitude, which is 7. Therefore, negative 3 divided by 7 cos negative 1. So we get our alpha is 115 degree. Then do the same for beta. 2 here, 2 divided by 7 cos negative 1. So we get our beta is 73.4. Then for our gamma, 6 divided by 7. So we get our gamma 31 degree.